Okay, so right now we have learned a bunch of different ways of solving right triangles, right? All the different pieces. If you're given two sides, right, you're given A and B, you can find C by the Pythagorean theorem. If you're given two sides, let's say you're given A and B, then you can find the third side, or you can find one of these inside angles, right? And you would use that using trig functions. Sorry, inverse trig functions. Like the sign with a little -1 up there, for example. And then there were also cases where you were given one angle and you were given one side. And in order to find the other sides, you again would use trig functions. SOHCAHTOA, right? SOHCAHTOA, SOHCAHTOA. Make sure whenever you take a test or do homework, you write this at the top. It's going to help you remember the different pieces of it. All right, so what we're going to do is apply what we know about right triangles and all these methods to solve the stuff to application problems. And that's the basis of the whole thing, is get that picture drawn. There will be a right triangle involved with every single problem. You just have to label the correct pieces accordingly. So draw the picture best you can. It's not art class, so it doesn't matter if it looks horrible. Then label it. You're given some information. You've got a variable to put somewhere. Do your A, B, C, capital A, capital B, capital C if you need to. Then make sure that you identify the O, A, and the H. Just like before, you had to pick which trig function do you need to use, and then you're going to solve. For example, this one says, a ladder leans against a brick wall. The foot of the ladder is 6 feet from the wall. The ladder reaches a height of 15 feet on the wall. Find to the nearest degree the angle the ladder makes with the wall. Okay, so here's a picture that I drew, but even as simple as going, oh, here's my building. Here's my ladder, right? It starts at the ground and goes somewhere up here on the building. And then making your right triangle. And then it gives you certain pieces of information. It says the foot is 6 feet from the wall. Well, here's the foot. That means this is 6 feet. It says the ladder reaches a height of 15 on the wall. So here's the wall. That 15 must go here. And then it asks for an angle. So we're either talking about this angle or this angle down here. Now it says the one that it makes with the wall. So here's the ladder, here's the wall. That's the angle that you're going to be looking for. If it had said the angle with the ground, then that would have been the one over here. Okay, looking at what we got. We're trying to find x here. X is in this corner for us. We found that this is 15 and this is 6. So I'm looking at it and I go, okay, here's my angle, so that's my opposite. This is my adjacent. Here's my hypotenuse. Now I could use the Pythagorean theorem and find that third side, the hypotenuse, but I don't need it. I'm trying to find an angle, so if you don't need it, don't find it. Okay, x, I've got opposite and adjacent, which is tangent. Tangent of x equals opposite over adjacent. I don't know why I wrote that all out. So tangent of our angle is 6 over 15. Easy to find angles. X equals, and then you do the inverse of that guy with a little -1, and just plug your fraction in. Looks like that comes out to be about 21.8. But it says to round to the nearest degree, so we're going to say 22 degrees is that angle right there. The hardest part of these is getting that picture up there, but once you have the picture and you have your right triangle drawn in there, label your stuff, pick your trig functions, and then solve. Okay, let's look at this one. Similar, it's another ladder. Man wants to determine the height of a wall. Okay, ladder is leaning against a vertical wall, makes an angle of 20 degrees with the ground. The foot of the ladder, that means the bottom of it, is 3 meters from the wall. Find the length of the ladder. So we've got this wall, right? Here's the wall, just in case you weren't following me. This is the wall. Here's my 90-degree angle. This is my ladder. Put some rungs in there. Not a very sturdy ladder. Let's see, it says that the vertical wall, it makes a 20-degree angle with the ground. So here's the ground, which means this angle right here is the 20-degree angle. The foot of the ladder is 3 meters from the wall. So foot of the ladder, 3 meters from the wall. Here's the wall. Here's the foot of the ladder. So this guy right here is going to be 3 meters. Okay, then it says to find the length of ladder. Find the length of the ladder. And I'm missing a whole line here. It's supposed to say find the length of the ladder and then the height of the building. Let's just focus on the length of the ladder. All right, here we go. Looking at what we got. We need this guy right here. That's the ladder, and that's his length. So in my right triangle here, this is my hypotenuse. This is my angle. And I know this guy here, then I can use a trig function to finish solving for it. So what I've got here is adjacent over hypotenuse. Let's see, adjacent hypotenuse is cosine. So cosine of my angle, 20 degrees, equals adjacent over my hypotenuse. Now we talked about this in class about how when the variable's on the bottom, you can just swap places with these guys. That's the gist of how you solve for them. So it becomes x equals 3 over cosine of 20 degrees, which is about 3.2 meters. Everything's in meters. These must have been written by somebody across the pond. Across the pond. So yeah, this is the trick right here. If the variable is in the denominator, then it's the number divided by the whole trig function. If the x variable is in the top, if it's in the numerator, then it's the number times the trig function. And then that's it. You just plug it in and solve. Ben and Emma are out flying a kite. Emma can see that the kite string she's holding is making a 70-degree angle with the ground. The kite is directly above Ben, who is standing 50 feet away. To the nearest foot, how many feet of string has Emma let out? Now this is going to require a lot more artistic ability. Let's see, there's Emma, right? She's holding on to this string out here, and there's the kite. What do they have, the little strings on it? Whatever, close enough, right? Oh, there we go. There's Emma and her kite. And then the kite is directly above Ben, so Ben must be far away, so he must look a little smaller. Ben, Emma. All right. Ben is flying a kite. Emma can see the kite string she's holding is making a 70-degree angle with the ground. So right here, now this isn't the ground, but it's parallel to the ground. So we're going to consider it to be the same thing. Okay, 70 degrees right there. And notice I drew the line out to Ben because it tells me that the kite is directly above Ben, which means I can now draw a perpendicular line from the kite down to Ben's big old head for his little tiny stick body, and that forms my right angle. Okay, he is standing 50 feet away. 50 feet away corresponds to this guy right there. Then it wants to know how many feet of string has Emma let out. That's going to be this last piece up here. And that's our unknown. All right, we now have our right triangle. Emma's over here. We've got 50 down below, 70 here, and we're trying to find X. All right, let's label. Let's see, theta is 70. I'm given an adjacent of 50, and we have to find the hypotenuse. Okay, adjacent hypotenuse. In my head, I'm saying SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Okay, looks like it's going to be cosine. Cosine of theta is adjacent over hypotenuse. Cosine of 70 equals 50 over x. Now, we're finding the hypotenuse, which means you're going to be taking the number and dividing it by the trig function. But again, I'm going to show you why, so that those of you that want to have the understanding can see it. Multiplying both sides by x, it gets rid of it in that denominator. So now it looks like this. X times the cosine of 70 degrees equals 50. Feels weird, but our next step is to divide by that trig function. Whatever you do to one side, you have to do to the other, because it cancels it over there on the left side. Okay, x equals 50 divided by the cosine of 70. Okay, that is about 146 feet. Makes sense, you know, 50 yards out, all the way up into the sky, 146 feet. Just a note right here, remember I showed you a shortcut. When the variable is in the denominator, like we had cosine of something equals a number over x, then to solve for x, these guys swap places. So x equals the number divided by the cosine of whatever the angle is, right? Normally when the x is in the top, then it's the number times the trig function. Too many words, but there's the answer to that one.